Now that we've covered the idea of what forces are, now we're ready to move on to adding and subtracting forces. As we saw in the example with the school bus, forces can actually cancel each other out. If you're pushing in one direction, but friction's pushing back in a different direction, they're going to cancel. Now sometimes they don't cancel exactly. For instance, you might exert a force, and friction might slow you down, but not stop you entirely. And in this case, you then have to add the forces and see exactly how much of your pushing force remains. So this lecture, we're going to go through and talk about how forces add and subtract from each other and what the easiest ways to do that are. Now in one dimension, it's really easy. Forces are either in the positive direction or in the negative direction, and you can just use positive forces as positive and negative forces as negative. So we have a 10 Newton force in the positive direction and an 8 Newton force in the negative direction. That's just 10 minus 8 newtons, which is 2 newtons. And because it's positive, we know that this new force is in the positive direction. Now in 2 or even 3 dimensions, this gets more complicated. In this case, often one of the easiest ways to visualize this is called the parallelogram method. And it's called this because let's say we have two forces. They're both acting on the same object. We have force 1 and force 2. And we can think of these forces as arrows. So at the end of force 1, we can start our second force. And since they're end to end, they'll add together. So at the end of force 1, we'll draw force 2. And this gives us a new force, which is the net force, force net, that connects the two. And to check to make sure we did it right, let's draw force 1 on the end of force 2, because order shouldn't matter. So we do this, and do approximately the same one, and we find out we get the same force either way. So we know we did it right. Now there's some easy mistakes you can make if you add them in the wrong order. For instance, if you go from tip to tip, like this, with force 1 and force 2, then you haven't actually learned anything, you haven't made any progress. Or if you start them in the same spot, if this is your spot, and you draw force 1 and force 2, then you can see both the forces acting on the object, but you can't see them added together. So you have to go from tip to tail. You add the tail of force 2 over here onto the tip of force 1, and combined they give you a new force. And you can actually do this with multiple forces, just keeping adding them onto the end. So you have the total sum of forces, and you can see exactly which way the net force goes. And the net force, it just means whatever all the forces add up being. So if the net forces are 0, then there's no acceleration. If the net forces are small, there's a small acceleration. And the direction of acceleration is always in the direction of the net force. And we can write this net force as sigma force. This weird looking sideways M is called sigma. It's a Greek letter meaning sum of. So this means when you add all the forces together, what do you get? And different problems will get different things for that. And a lot of times, that's the most useful thing to look at, because it's telling you how the object behaves. We've now talked about how you add forces together by drawing a parallelogram, but that's not that useful. You want to do a physics problem with actual numbers, because you actually have to be able to add the numbers together. So you have to do it numerically. What you have to is you have to define a coordinate system. So we'll say x and y. And this sounds confusing, but basically this is just a way of describing directions. And then with the forces in the coordinate system, let's call it force 1 and force 2, you find out what the x and y components of the forces are, and then you add them together. So force 2 has an x component like this, and force 1 has an x component like this. They add together to make this force. We'll call it the sum of forces x. And similarly, if this is the y component for force 2, and this is the y component for force 1, then they add together to make force, the sum of forces in the y direction, and then we can add this together, just like we did last time, and it gives us a new force. So I'll give you some practice with this in the practice problems, and then you're ready to move on to the concept of net forces and how that affects physics and Newton's laws.